Okay, sorry. I spent some time trying to fix the recording because this is required by the Asia University. I have to record 5 to 6 classes of this course. Okay, so I need to fix up the equipment, recording equipment. Okay. Anyway, I already fixed it. Okay, so before we start, let's review what we have learned 2 weeks ago, because last week we have a holiday, right? So hope everyone enjoy your holiday, because during the holiday I've been to the Mazu. I mentioned in last time. I tried to bring you to the Mazu parade because it's a very popular activity in Taiwan. But unfortunately, I was not able to bring you there because I have something to take care of. Okay, so I'm not in a good position to take you there. But anyway, this week, tomorrow I will go there as well, because this is another parade in Changhua. Okay, Changhua is very close to Taichung. So I just hope that during your stay in Taiwan, you can also spend a little bit more time in understanding the culture of Taiwan. Okay, I think that would be very interesting. But of course, you can also find a lot of information from the YouTube. Okay, I think that would be very nice. Okay, so this just a minute. Okay, so last time we talked about the logistic regression. Okay, so basically what we are doing here is doing the one topic about the classification. So classification is very important in our data analysis. Actually, there are so many approaches discussing classification. Okay, so here, because this chapter, chapter 4, is focused on classification, so this textbook will contain many different topics in classification, but not limited to the topics contained in this textbook. There are also lots of classification approaches out there on the internet or on other materials you can reference. Okay, but what I like you to be more focused is the simplest way on the classification, which is the logistic regression. Okay, of course, in the following lecture, we're gonna discuss some more advanced classification approaches. Okay, for example, like linear discriminant analysis, quadratic discriminant analysis, naive, Bayes, and k-nearest neighbors. Okay, so all these approaches are widely discussed in the literature and the textbook. But there's one more thing I'd like you to note is that I just found there's an updated textbook of this updated edition of this textbook It's being updated in 2023. Okay, so I like you to search for this updated because I found there's some errors being corrected. So in this textbook, in this newly revised edition textbook, you probably can find some different materials in there. Okay, so it's very easy to download the textbook. Okay, you can just type the textbook name, introduction, statistical learning. Okay, introduction to statistical learning. Okay, and you will see the first page. Okay, pop up on your screen is this textbook website. Okay, so you can click this click this link. Okay. Wow. Okay. Okay, and then you can see this website here. Okay. Download ISR with download ISL with R and download the ISL with Python. So basically, the Python edition has been published as well. So if you like to use Python to do your homework, you are welcome to do that. Okay. Similarly, in my portfolio course on Monday, some student asked me if he can use Python to do the homework. I said no problem. If you are comfortable with using Python, you can use Python to do the portfolio course or portfolio homework or test. No problem. Okay, but I myself I'm more familiar with R, so I'm gonna follow R, and I'll give you R lectures. But of course, if maybe someday in the future you like to be more focused on the machine learning part or data analysis part, you are encouraged to use Python, no problem. Okay, because these two softwares are free software. Okay, you don't have to pay the any fees using these two software. So there are so many free materials on the internet that you can reference. Okay, so let's come back to the next. Okay, I just made some slight modification of the PowerPoint. Okay, but not much different. Okay, not much different from the previous edition. Okay, so what we are going to do is what we are going to learn is about the classification. So basically, the classification involves many different aspects, but from the easiest part, we learned logistic regression. Okay, in logistic regression, our response variables are just yes and no, or right or wrong. Okay, or 1 and 0. So basically, this is what we are dealing with. Okay, response variables involves just 0 and 1. Okay, so that's the easiest case. But of course, based on this, we are moving one step further. For example, like maybe we'd like to analyze more different types of response. Okay, so for example, like in this case, we talked about the multinomial logistic regression. Okay, so let's see, have here. Okay. Oh, okay. So there are a few topics that we haven't covered yet this time because when we generate the results of the logistic regression, okay, The thing is that you need to know how to interpret the results. Okay, so here I also gave you some slides about the interpretation. Basically, I think you won't have problems in interpreting the results of logistic regression. Okay, because sometimes you need to transform the results into the probabilities, expected probabilities or predicted probabilities, or sometimes you may interpret the results in log R's. Okay, log R's. So for example, like in this case, in table 4.1, okay, this case is about student, the default probabilities, okay, based on the student credit card balance, okay. But in this case, we also considering the non-student data. So here we don't include the student or non-student status here. So you can see in table 4.1, okay, we just run a very ordinary regression data here, okay. So you can see the estimated coefficient of the logistic regression model that predicts the probability of default using balance. Okay, so in this case, 1 unit increase in balance is associated with an increase in the log odds of default by 0.0055. Okay, so what does that mean? We have to go back to this logarithm because in logistic regression, what we are analyzing is the on the left hand side here, we call this as log odds or logit. Okay, so this represents the win or lose. Okay, the ratio of winning or losing. So we call this log odds. Okay, but maybe we are not so familiar with the log odds because in the Western culture, okay, Western culture, they like to use win log odds. But in Eastern culture, okay, for example, in Taiwan, we tend to use the probabilities, okay, to represent the likelihood. So if that's the case, then we need to do some transformation, okay. So you can see this is about the logistic regression. We can just transform the log odds, okay. We can do some transformation. So in the following, we can use this. Just a minute. Okay, in this slides, you can reference the codings, and then you can find the results here. Okay, this is the results. And in this case, we can transform the data into the. Just a minute. Okay, so if you want to transform the results into probabilities, then you can reference this example. Okay, for example, in this case, if we have different balance, okay, credit card balance, in this case, based on table 4.1, you can calculate the predicted default probabilities for the individuals with credit card balance of 1,500 and 2,000. So based on this, then we can do some transformation. Okay, so in this case, you can see here, because here I just show you the slice of the codes. Okay, but you can try by yourself. Basically, we need to calculate the beta first. Okay, and then based on this, okay, based on this beta, then we can plug in plug into the equation. Okay, so for example, here we are taking the exponential of the sum underscore beta divided by 1 plus exponential sum of the beta. Okay, so maybe we can reference the textbook here. Just a minute. Because it's easily available from the internet, so I suggest you can also download the textbook as well. Okay, here we are. Wow. Oh, okay. I don't know why this internet speed is so slow in this classroom. I need to tell the assistant. We have to wait for a while to complete the downloading. Okay, but anyway, we can use this formula to calculate the probabilities. Another useful function is that we can also use this function. This is called PLOGIS. Okay, PLOGIS. PLOGIS means probability or logistic regression. So we can just use this, okay, to calculate the probability. Okay, so that will be much easier, okay, for you to calculate the probability. So this is about how to calculate the predicted the probabilities, okay. Okay, and other cases like if we include student status here. Okay, so for example here in table 4.2, now we include the student, and now the student it can be treated as a dummy variable. Okay, for example, with the value 1 for student and the value of 0 for non-student. So in this case, we can also run this logistic regression. We can also generate the table like this. Okay, so this is the codings just for your reference. And this coding, if you want to generate a table like this, you need to install other packages like GT and the GT summary, etc. Okay, so this is also useful for you to generate the tables in the future. From my viewpoint is that because this is not that difficult, so I also encourage you to install this package, okay, so that you can generate the output easily. And as far as I know, this package can also generate the output and save in different types of file format. For example, you can save the table output in the Word document, or you can save the output in PDF document. Okay, so it's very easy and convenient. Okay, so this is about the logistic regression. And then we can also include more variables in table 4.3. So you can see table 4.3, we can, now we include more variables. We have balance, income, and the student, okay? So in this case, we can generate the tables down below here and at the bottom, the right here, okay? You can see this intercept, student, balance, income, and in that case, we can also generate the output here, okay? So here is the output, including by considering the credit card balance and default rate. And we can also see the student status, yes and no, okay? And to see their distribution of the credit card balance. Okay, so this is an interesting case. Okay, I just need you to know that. Okay, so based on this, we can also regenerate the predicted the default probability for student. Now, for example, we have a student status and the credit card balance and the income of 40,000. Then we can calculate the default probabilities. Okay, so this is not that difficult, so we can use this. Down here, we can also use another case. This case is about employee attrition. Okay, so this is also a very popular example in data analysis. We try to examine the data, the employee attrition, the reason of the of employee attrition based on several factors or explanatory variables. So this is the attrition. Okay, so before we start the analyzing, we still have to do some changes in our data. So basically, whenever we want to use the logit regression, if we want to study the classification issues, you have to know that you need to change the data format into factor format. Okay, so originally maybe the data is 1 and the 0 in numerical format, but in your function using the logistic regression or generalized linear regression, you need to convert data into factor, okay, factor data. So that's why here we need to convert the attrition data into the factor data. Okay, so you can see we have a mutate if to check if the data is factor or not factor. Okay, so this is about the attrition analysis. On the other hand, in this case, we also include more complicated process. For example, like usually in our data analysis, we like to split out data into two parts. One is a training data set, another is test data set. Okay, maybe training data set will include 70% of our sample, and 30% will be treated as a test or training data, as a test data set. Okay, so we have a training data set, we also have a test data set. Okay, so similarly in your finance studies, okay, we for example, like if you like to test if some specific signals or indicators are useful or not, maybe you have to split your data, okay, into training and test. But besides that, in finance, we like to see more is about how this model is working in real data. For example, in your portfolio course, okay, you can generate a very good portfolio based on the risk and return. But if you want to make your investment, you have to evaluate if this investment portfolio performance is good or bad. In the future, you have to do some rolling window testing. Okay, so that's why in finance we like to use the back testing approach. Okay, so this is very important in your finance study in the future. But now, because we only have a block of sample data, okay, so the only way to test our model is to use the test the sample data set, okay, to evaluate the model performance. Okay, so this is about the simple logistic regression, and then we can also follow in the codings here. The coding is not that difficult, so basically you can just use these codings, okay, and try to plot the results. So this is the plotting of the results, okay, and this is referenced on the internet resources. Okay, so I will give you the codings later. Okay, I will post the codings on the Tron class so that you can run the codings directly. But don't worry about the coding right now. Okay, what we really care is about, okay, so if this model good enough in our prediction for the future, okay, or in our data analysis. So what we really care is about the how this model is performing in terms of its prediction accuracy. Okay, so based on this, we have other metrics to measure the prediction accuracy. Okay, so down here are just the model output here. Okay, so this is just for your reference. Okay, so assessing the model accuracy. So how well do our model predict? And now we have, suppose we have 3 models to evaluate. For example, if we, the first model is monthly income, okay, that means is monthly income related or can explain the attrition, or the second model is monthly income and the overtime, okay, can better explain the attrition, or the model 3 will include all variables in our model, okay, and if this model 3 can better explain the attrition. So we like to assess the model accuracy. Okay, so if we want to assess the model accuracy, there are many approaches in data analysis. Okay, and this is not that difficult to understand. But in this case, okay, we are using the CV approach. Okay, CV approach, which means the close validation. Okay, the close validation is a different approach to sample the data, and that means we can go through this process, okay, to get a better representation of the sample data, so that we can better evaluate the result here. Okay, never mind. We just try to generate 3 models. Okay, so in this case, the first model is attrition till the monthly income. The second model is attrition explained is explained by monthly income and the overtime. The third model, okay, is the attrition explained by all variables in our data. Okay, and of course there are other setup in this train function. We set up the train control equals to train control method is equal to CV. Okay, number equal to 10. So that means we are using a 10-fold close validation to extract the sample. Okay, so if you don't know the approach here, no worry about that. Okay, this is just a method to extract the sample from our data. Okay, so based on this, then we can generate the results of the 3 models, and then we can extract out of sample performance measures. So here we have some measures here. Okay, so you can see here both CV model 1 and CV model 2 had an average accuracy of 83 point I think it's 83.95. Okay, it's not right here. 395. Okay, it's 83.95. I don't know why I have this number here, but the average accuracy here is 83.95, 83.95%. Okay, but model 3, okay, is a little bit higher, okay, which is 87.1%. 87.15. So Model 3 seems better, performs better than Model 1 and Model 3. Okay, so this is outer sample performance measures. Okay, so this is just for your reference. And then we also have other classification measures, for example, like confusion matrix. So this is, we like to call this as confusion matrix to evaluate the certain performance measures. Okay. And this confusion matrix will be applied to the some categorical levels, categorical data. Okay. Okay, so before we start this, let's take a break first. Okay, I'll be back later.